We're live. This is Math 60, Intermediate Algebra, and we're in the middle of 3.2. We're doing substitution and elimination, mostly elimination, and we're solving systems of equations. And as I promised you, these are the ones that are not as fun. Yay! Matt Damon says he doesn't care. He wants you to solve this problem. Look at him. Look at him. He's serious about this. Okay. So first thing I see on this one is that I have a big mess. So what I'm going to do is I'm going to simplify each of the two equations. So the first equation is 4x equals 3 times the quantity 2 plus y. And the other one is 3 times the quantity x minus 10 equals negative 2y. So I'm going to go ahead and start with the first one. I'll multiply out using the distributive property. 4x equals 3 times 2, which is 6, plus 3y. And then what I'm going to do is I'm going to go to the extra step to move the x and the y on the same side. So I'm going to subtract 3y from both sides so that I get 4x minus 3y equals 6. And these cancel out. Okay, let's come over here. I've got 3 times this quantity, so I'm going to use the distributive property again. 3x minus, 30, no one noticed, equals negative 2y. Now, I could leave it like this, but I want it to line up with this one. And this one I have x and y both on the left-hand side. So I'm going to go ahead and move x and y onto one side and the number on the other. So first thing I'm going to do is add 2y to both sides. Now, it is going to get a little crowded on the left-hand side because I'm going to have 3x plus 2y minus 30 equals, and then a lot of people panic at this point. Matt Damon says, don't panic. Negative 2y plus 2y is 0. That's all. If everything cancels itself out, you're still left with 0. It's a nice placeholder. It's really great. And then I'm going to add 30 to both sides. Woohoo! And then I get 3x plus 2y equals 30. Bam, not too bad. So I've got my two equations. A couple things we could have considered, which I wanted to use elimination to do this, but at any point along here, you could have chosen to do substitution, in which case, for example, you could have tried solving for x or for y, if that's the direction you want to go. I'm going to use elimination. So elimination says I take the two equations, 4x minus 3y equals 6, and 3x plus 2y equals 30. And I think about what I could do to multiply everything here by one number and everything here by another number so that somebody would cancel. Now, I could cancel the x's, that would be fine, but they're both positives, which means it'll be a little harder. With the y's, one is already negative. So I've got a negative 3 and a positive 2. What number that's larger do they have in common? Sorry. 3 and 2 share 6. So I want to go for 6. So to get to 6 from 3, I have to multiply by 2. Down here, because I have 2, I have to multiply by 3. Let's look at what that looks like. I take 2 and I multiply all the way through everything. So 2 times 4x is 8x. 2 times negative 3y is negative 6y. 2 times 6 is 12. So I've transformed this whole equation into this whole equation. Now down here, I'm going to multiply by 3. So 3 times 3x is 9x. 3 times 2y is positive 6 times y. And 3 times 30 is 90. Now, if I did this transformation well, somebody should cancel out. And you can see right there, the 6's, negative 6y, positive 6y, cancel out. So on the left-hand side, I've got 17x. On the right-hand side, I've got 102. Now, normally I would worry about this, except that I happen to know that this works out. 17x all over 17 equals 102 over 17. And believe it or not, it's 6. And I can hear you not believing me. So we'll turn this on. 102 divided by 17 is 6. And the way that I figured that out was I was thinking, oof, what times 7 gives me that 2? And I realized 6 times 7 is 42. It's kind of cool. Okay, so now I've got x. I need to find y. Now it's up to you which of the equations you use, because you've got a whole bunch of stuff and you could plug it in pretty much anywhere to find y. What I might do, there's a lot of equations running around. I think I'm going to go ahead and use this one. So we need to find y. Take the 4x minus 3y equals 6. Plug in the x equals 6. So 4 times 6 minus 3y equals 6. So 24 minus 3y equals 6. 24 minus 3y equals 6. Subtract 24 from both sides. Negative 3y equals negative 18. Negative 3y over negative 3. I'm running out of room. Oh my goodness, over negative 3. Y equals 6 as well. What a surprise. Oh my goodness. Kill surprise. Okay, so normally someone might think, thank goodness we solved the problem. But of course we know better. We know that number 4 has to be checked. So I've got, let's see, I've got x equals 6 and y equals 6, or 6, 6. So that's my answer. And let's try the check. Now remember, the check means we have to go back to the original. So 4x equals 3 times the quantity 2 plus y, and 3 times the quantity x minus 10 equals negative 2y. So 4 times 6, does that equal 3 times 2 plus 6? So 4 times 6 is 24. Over here, this is 3 times 8. That's 24. Oh my goodness, they match. Woohoo. Okay, can you do the other check on your own? Yes. Awesome. So go ahead. Anytime you want, pause the TV. We've got a creeper over here. Matt Damon wants to see if we solved the problem. Anytime you want, pause the video and work it out on your own. Make sure I'm getting the same thing you're getting. I'm going to plug in the 6 over here, question mark, negative 2 times 6. So I get 3 times negative 4, which is negative 12 over here. And over here, I get negative 12. Oh my gosh, they check. Now, is it happy Matt Damon or sad Matt Damon? Well, there's a single answer. If there's an answer, it means it's one of these. It's an X. There's a single point where we can build that spaceship, which means happy Matt Damon. Yay! Okay. I know there was a lot of excitement for one problem. You ready for a lot of excitement on another problem? Now, something you should know about me is if the problems suddenly get easier, you should be very, very suspicious. So what I'm hoping you'll do, I'll go ahead and rewrite this one slightly bigger so you can kind of see it better. 5x minus 9y equals 7. 7y minus 3x equals negative 5. And what I'd like you to do is take a look at that, maybe pause the video if you're not sure, and tell me why you think this is a hard problem. Because it really is. A lot of people miss this. So let me give you a second. Okay, so what makes this hard? Well, if you said that I have sneakily lined up the x and the y and the x, so they're lined up in the wrong way, that's exactly it. And sometimes the problems will be like that. And boy, is that frustrating. So first step, I'm going to take 5x minus 9y equals 7. And then I'm going to write the second one as negative 3x plus 7y equals -5. Now I've got the x's lined up and the y's lined up and the equals lined up. That's really, really important when we're doing elimination. Okay, so you've got two choices. We can try to eliminate the x's or the y's. For the x's, what number would you be aiming for? You're right, 15. For the y's, if you want to get rid of the y's, what number are you aiming for? This one's a little harder. Basically, yeah, it's going to be 63. 9 and 7 both go into 63. 5 and 3 both go into 15. I'm going to usually go for the smaller one if I can. It's just going to make my numbers easier. But you could do either one. It does not matter. So if I'm aiming for 15, this one's already negative. So we got a positive and a negative, which is awesome. So up top, I'm going to multiply by 3. Down on the bottom, I'm going to multiply by 5. So up top, 3 times 5x is 15x minus 27y equals 21. Really important, don't forget the number. A lot of times people get so excited about the left side, they forget about the right side. Make sure you multiply that side too. 5 times -3x is -15x. Good, these are going to cancel. 5 times 7y is plus 35y. And again, 5 times -5 is -25. And when I add them, sure enough, this becomes a big fat 0. -27y plus 35y is 8y. And this is -4. Okay, so next step, I have to solve for y. So I'm going to divide by 8. Y equals -1/2. Woohoo. Not really woohoo. Anytime we bring in fractions, it's like, oh, we got fractions. But we got an answer. So I'm going to come around over here. Let's find x. Woohoo. Let's see if we can find x. Okay, so I've got y equals -1/2. I'm going to go ahead and just use the first equation. I'm going to plug in y equals -1/2. 5x minus 9 times -1/2 equals 7. So 5x plus 9/2 equals 7. So now this is where it gets kind of ugly because I don't know about you, but it's pretty late at night when I'm recording this, and I just am not up for some fraction shenanigans. Normally I'm down for fraction shenanigans, but not right now. I just don't feel up to it. So I'm going to look at the original problem, and I'm going to see that there are no fractions and no decimals, which means that I'm not getting any hints about which way I'm supposed to go. The denominator is 2, which means that this is going to be a really beautiful decimal. Right? It's a terminating decimal. So I'm going to go ahead and use decimals. I'm going to say, you know what? It's time. It's too late. I'm going to do 4.5. 9 divided by 2 is 4.5. If you're not sure, calculator. Okay. Subtract 4.5 from both sides. Okay, I've got 5x equals. Now I need to know what this is. So you can always do it here. I happen to know it's 2.5. But you can calculate that. Okay, so if 5x equals 2.5, then 5x over 5 equals 2.5 over 5, or x equals, and I happen to know that that is going to be 0.5 or 1/2. What do you guys think? So you could double check. 7 minus 4.5 is 2.5. If you take 2.5 divided by 5, you get 0.5. Now, the one thing you can't do is you shouldn't give a mixed answer. So if I'm going to say x is 0.5, I'm going to say y is -0.5. Put them both in fraction or decimal form. 0.5, -0.5. Okay. Woohoo. Shall we go ahead and, where did I put all my extra paper? Let us go ahead and check. So for my 5, my check, I've got 5x minus 9y equals 7. and 7y minus 3x equals negative 5. Remember, you always check the originals. Always. Because you never know when you might have made a mistake. And you've got x equals 0.5 and y equals negative 0.5. And it is perfectly fine. If you prefer, if you're like, wait, I'm up for some fraction shenanigans, go for it. Do the fractions. You will end up with the same results. Okay, so 5 times 0.5 minus 9 times negative 0.5. Does that equal 7? Now this equation is the one that we used to find x. So technically this check is not necessary. I'm going to do it anyway. 5 times, now notice 5 times 1/2 of 5 is 2.5. Another way to look at it is 5 times 5 is 25, but you move the decimal point in 1. Okay, this is going to be plus. And again, either half of 9 or 9 times 5 is 45. And then you move the decimal point. 2.5 plus 4.5, that's equal to 7. Woohoo! Let's try this one. 7 times y, which is negative 0.5, minus 3 times 0.5. Does that equal negative 5? So 7 times 5 is 35. Slip the decimal point, or half of 7 is 3.5, but it's negative. So negative 3.5. And then 3 times 0.5 is negative 1.5. Now, if you were like me, when I see this, I thought it was going to be 3.5. My brain was not thinking multiplication. So remember multiplication, so we get that. Does that equal negative 3.5 minus 1.5? You can always double check it. Remember to use the funny negative. Negative 3.5 minus 1.5 equals negative 5. We did it! Yay, yay. Okay, so now the question is, do we have a happy Matt Damon? Matt Damon wants to know. And the answer is yes, we got a single answer. This answer is a single answer. So Matt Damon is saved. Okay. Next up, you should be getting really nervous now. Really, really nervous, because this problem looks, sorry about this, I'm having paper issues, as we all do at some time in our lives. This one looks downright friendly. I would be very afraid if I were you. I'd be looking at this going, whoa, this something weird's going to happen. Something is absolutely weird going to happen. Now, the thing about math that's really, really important, the thing that makes it, I think, the most difficult of all the sciences, I mean, it's the one that causes the most fear for a lot of people, although, to be honest, chemistry also. But the thing about it is that your brain is so smart, your brain is going to go, wait a minute. I see a pattern and it panics and it wants to stop. And what I'm going to try to encourage you to do is don't stop. You could be wrong. Nothing terrible will happen if you're wrong. And if something goes badly, then either you go back and figure it out, or you get help from your teacher or tutor or people on the street, wherever you want. Have a math party. Eventually that's going to catch on. So I'm going to go ahead and approach this just like any other problem. I'm going to pretend I don't know that there might be anything weird going on. I'm going to say, okay, I got my A's lined up. I got my B's lined up. I'm going to try to cancel my A's. So in order to do that, I need to think of a number that 10 and 5 have in common. Well, they're both going to 10. But if I multiply by 2 in the denominator, or in the, the denominator, on the bottom one, if I multiply by 2, this would also be 10. They would have the same sign. So I need to multiply by, you got it, negative 2. So up top, I got 10a plus 6b equals 8. Down in the bottom one, I get negative 10a, negative 6b equals negative 4. And then weird things happen. And again, your brain's going to say, I do not want to do this because it's going to be weird. And you just say, hey, brain, I appreciate it. You are looking out for me, but we got this. We can totally do this. Even if you get it wrong, it's just a piece of paper. You can crumple it up, put it somewhere else. So let's just give it a try. 10a minus 10a cancels. 6b minus 6b cancels. Is there anything else? No. What do I write when everything is gone? It's a placeholder. It says there's nothing left. 0 equals 8 minus 4 is 4. And now we think about this. We think long and hard. And we say, wait a minute, 0 is not equal to 4. Like if you're totally broke, does that mean you magically have $4? No. No, this is 0 is not equal. This is false. And this is bad because our creeper Matt Damon is starting to lose a little faith. And we have to say, ooh, what does it mean that this is false? So what did we do? We started out and we said we need to find an A and a B that will solve both equations, right? That's what we're doing. That's what a system of equations is. We got the answer false, which means there's no solution. So we've got a very tense phone call with Matt Damon, who already seems to understand what's just happened. We've got no way to solve this. There is no way to build him a spaceship that will keep him cool and keep him oxygenated. It's just not possible. Oh, I'm sorry, Matt Damon. He didn't survive this movie. So let's talk about a few things. You need to say no solution. You need to be able to say parallel lines. What am I talking about? Well, if two lines do not ever intersect, what does that mean? It means that they're parallel. These are two parallel lines. We just didn't realize it because I made it fancy so you wouldn't notice. But that's why there's no solution. There's no overlap. There's no point where they intersect. Sorry, I'll do it over here. Wait. Oh, that's right. I was doing it with sad Matt Damon and thoughtful Matt Damon. They're not going to intersect. They're going to be parallel. Okay, so it's no solution. They're parallel lines. And this is called an inconsistent system. Right? It's a system of equations, and it's inconsistent in that we're saying this line and that line have to intersect, and they do not. Okay? You need to be able to say all three of these things. And in exchange, you do not have to check because there's nothing to check. There is no solution. So that's this weirdness. It's an inconsistent system because they're parallel lines. Woohoo! Shall we try another one? Okay, this looks nasty. Okay, but it's the last one, so I'm excited. Are you guys excited? I am so excited. I'm so excited I wrote it way too big. I'll write the arrow here. Okay. So I got 2s minus 13t equals 120. And negative 14s plus 91t equals negative 840. And so they're already lined up, which is awesome. And I'm either going to try to cancel the t's or the s's. I think the s's are easier. I'm going to multiply by 7 on top. 7 times 2 will give me a positive 14, which will cancel there. So 7 on top, nothing on the bottom, or 1 on the bottom. So my top one's going to be 14s. And then I have to go in and see, okay, 7 times negative 13 is negative 91t, at which point your brain goes, wait a minute, this is too scary. And you're going to say, don't worry about it, but don't worry about it, brain. Okay, 7 times 120. And then it's like, oh, spooky. Okay, so the whole first top equation, when you multiply by 7, you end up with something that looks just like the opposite of this. Okay, so the bottom equation is minus 14s plus 91t equals negative 840. And when I add them together, I get 0 on the left and 0 on the right. And the answer is that this is true. 0 equals 0, as opposed to the other one. 0 does not equal 4. That's false. This is true. Okay, so what does that mean? Well, it means it's true always. So in other words, we don't have 2 lines. We secretly have 1 line. Anytime you're on the 1 line, you're on both because they're the same line. So in fact, we've got a very happy Matt Damon. Yay! He's so much happier than the last situation. Doing a little dance. Happy Matt Damon. Here's happy Matt Damon. Whoa, yeah! Okay, so now what do we need to say here? Because you know, if mathematicians love anything, it's parallel structure. Oh my gosh, we go bonkers for that stuff. Okay, so I wrote false. I wrote true. No solution. This one is infinite number of solutions. Right? Every point on this line is a solution. All of them. How many points are there on a line? An infinite number, because it just keeps going forever. Okay, parallel lines, same line. Now this one's inconsistent system, which is kind of human and it's kind of English. This one's a little weird. It's called a dependent system. And the best way I can describe this is what that means. This is all that you have to say. And what that means is that it depends on more information. So in other words, for someone to take this information and make a spaceship, you would have to tell them more. You would have to say where you want to be on this line because there are too many options. So that's what this is saying. Now, in the future, you will need to find 1 or 2 solutions. It's not hard. So I'm going to show you how to do that now. I'm not going to expect you to do this. I can't remember if any of the homework does, but I'm not going to ask you on a test. So this is something I consider to be part of Algebra 3 or Math 90 at City College, is to find 2 solutions. So how would you find 2 solutions? Well, you would take the 2s minus 13t equals 120, and you would say, okay, well, what happens when t equals 0? So I've got 2s minus 13 times 0 equals 120, or 2s equals 120, so s equals 60. So we've got one solution, s equals 60, t equals 0. And then I want to find another one, and I'm going to pick when, and I'm making some clever thoughts, and so that's one of the reasons that I'm not going to require you to do this, because it takes some thinking about it. But I mean, it's not impossible. But what if I picked, and I know this is going to seem weird, what if I picked t equals 10? Then I've got 2s minus 13 times 10 equals 120. 2s minus 130 equals 120. Add 130, add 130. 2s equals 250, or s equals 125. Okay, so when t equals 10, s equals 125. So what does this prove? I found two different solutions. Well, if we look back, which I can't right now, but I can do a little sketch. I tried to convince you at the beginning, and hopefully you put some thought into it, that there were 3 possible situations. I told you that either we are here in a single solution, right? We get a single answer. Or here, these are parallel lines. no solution, inconsistent system. Okay, or that was number 2. And number 3 is they're the same line. They're an infinite number of solutions. And it's a dependent system. So, what is the point of doing all this work over here and finding 2 solutions? Well, if you find 2 different solutions, 2 solutions that work, could you be there? No, because straight lines can't bend. No matter how I intersect, I can't make it come back and intersect a second time. It's just one overlap. If they're parallel, they don't overlap at all. They don't touch. So there's no solution. One solution, no solutions. If I can find 2 solutions, it's got to be here. There must be an infinite number. If my only options are 1, none, or many, I must be in many land. But all of this is in your next class. I just thought, since I'm making a video anyway, we've gone a little long, I would tell you this. So those of you going on, you kind of have this in the back of your head. The rest of you got some free math. Woohoo! Who doesn't love free math? Woohoo! Okay, so we party on. And then the sobering thought is our very next section is 3.6. And it's all word problems. Woohoo! So make sure you have your security support animals around. Make sure you've got your Matt Damon or your bears or chipmunks or whatever it is. Something nice to eat or drink, maybe some tea, some relaxing music. And I'll meet you back here and we'll do a bunch of word problems and get really smart together. Woohoo! You guys are awesome. See you soon. Woohoo! Bye. Math on.